Hi, and welcome back to CMG, your math space. We just started with chapter 2 of our AKI-OLA core math series. In this chapter, we are tackling real number system. We did the first episode in this particular chapter, chapter 2, first episode. We were introduced to sets of numbers where we look at the natural numbers, whole numbers, and negative integers, and then integers as a whole. Now in this part, we are looking at real rational and irrational numbers. This is a subsection. First, we will tackle what rational numbers are. Then the subsequent one, we'll be looking at the various types or subsections. Right, so we are tackling rational numbers. Now, bear in mind, for the record, when we talk about real number system or real number, we have two major types, which are the rational and irrational numbers. So we are tackling rational numbers. So please stay tuned. Please stay tuned, right? Now, first of all, what are rational numbers? Some of them I'll just talk instead of reading. Some of them too I'll read. But basically, rational numbers are numbers that can be expressed as a common fraction. I mean, they can be expressed written in the form of a fraction or probably decimals, right? So yes, and then their denominator, if you say they can be expressed as a common fraction, it means that we have a numerator and a denominator, and this denominator cannot be equal to, under no circumstance should it be equal to, is 0. Anytime a fraction is the denominator of a fraction is equal to 0, that we can say it's undefined. And when you say undefined, that on its own is a broad topic or subtopic that you can be discussed. But in this particular real number or number system, if you say that a denominator of a fraction is undefined, we are basically saying that the denominator should not be equal to 0. Right, so let me not talk too much. Let's read. I think the reading will make things simpler and tailor things down, managing my time. So now, rational numbers are numbers which can always be written as a common fraction. That is, rational number can be written as an integer divided by another integer. So we are just talking about a fraction. Now, in particular, they are numbers which can be expressed in the form of a over b, numerator and denominator. That's what we're talking about, where a and b are integers, but b must not be equal to 0. b not equal to 0. You see it here. Now, for example, 1 over 2, negative 7 over 45, and blah blah blah, right, are all rational numbers because they can be expressed as a fraction. Right, now the set of rational numbers is denoted by the symbol Q, so bear in mind. Now let's look at the various types under rational numbers, right? So it means that even though we have the major types, rational and irrational numbers, under real number system, when you take each of the major type, we have subtypes. That is what it means, and you have to take note of these. They might, as much as they may sound common and easy, we are starting afresh the chapter, so I'm not leaving any stone unturned. That's what I'm doing, so that when I go ahead and be teaching, I know I have covered these topics, and for that matter, I will not be fumbling or be wondering if you really understood or understand what we are talking about. So that's why I'm taking my time, the pain to do this. Now, first one, we have proper fractions. Proper fractions means that we have a numerator and denominator, but the denominator is always bigger than the numerator. The numerator is the number at the top, and then the denominator is the number beneath. That is what it means. So the same thing applies to the other fractions. And you can also, in fact, ascertain that all the denominators here are bigger than their numerators. That is it. Now let's look at improper. Improper. If something is proper and now we have said it's improper, it's just the opposite, the other way around. So here we have 10 over 3, 5 over 2, 129 over 22. All these, we can see that the denominators are bigger than the numerators. That is it. Now let's move on to mixed fractions. Now, mixed fractions, we have a whole number and a fraction attached to it. That is a mixed fraction. It is but mixed up. So we have a proper fraction or even improper fraction, but here the point is that there's a whole number, and this is how they are represented, right? This. So I think you can see them from the screen. So we can see one whole number 2 over 5, which is equal to 7 over 5, right? If you want to know how this were turned around to get this, what it means is that 5 multiplied by 1 is 5. Then you add the numerator to whatever you got. So 5 times 1 is 5, then plus 2, which is 7. So now that number that you got will become your numerator over the denominator. The denominator does not change. So 7 over 5. Here, 3 times 8 is 24. 24 plus 1 is 25 over 8. The same thing goes on. Now let's move on to integers. Now we already have a glimpse of what integers are. We are saying that integers are whole numbers, either negative or positive, with the number 0 inclusive. So 0 can be expressed as 0 over 1. Now bear in mind, 0 can be expressed as a fraction, and all whole numbers can be expressed as what? A fraction, right? So here 0 over 1 is equal to 0. So what it means is that any 0 over any number is what? 1 is 0 over 1, right? 0 over any number is what? Is 1, right? So that is it. Now 1 itself can be expressed again as what? A fraction. So what it means that any whole number, like we were saying, any whole number, either 5, 6, any number that you are given, it can actually be expressed as a fraction. But just that there's no need writing a whole number over 1, unless you need that in the calculation or whatsoever where it is needed. So that is what it means, right? So 1 itself is 1 over 1, but 0 over any number is 1. 0 over any number, bear in mind, note, 0 over any number is 1. I'm repeating this. Now let's move on to terminating decimals. So terminating, a special property that you should know, or it should be a takeaway with you when it comes to rational numbers, is that they are terminating decimals and then recurring decimals. What does these terms mean, right? So if you have this fraction 0 over 1, this 0 over 1 can be expressed as 5 over 10, right? What it means is that if I should write this 0, this 0.5, right, you just have to move it where the point starts, put your pen or your marker, whatever it is, and then be going in that moving in that right section until you get to the last point behind the last digits, right? I hope you get it. So what does this mean? So we have 0.5, right? If I want to get the fraction form of 0 over 0.5, it's only, I put it here, I move it once. When I move it, I have 5 over 0 because I moved once. So something like this. If I move it to the last point, there's nothing behind a 5. So that is as simple as that. Now, so I have 5 over 10 because there's only 1 point. So 1 0, right? So I think I'm taking too much time here. Don't worry. So the same thing for negative 0.731. So we are moving it how many times? 1, 2, 3. So 3 steps. So 3 zeros. So the number over what? 1 over that. So that will be 1000. The same thing applies here. How many times are we moving? We are moving 1, 2. So we write the whole number 106 over how many steps? 2 zeros. 1, 2 from the point. So that is it. So now let's look at recurring decimals, right? So here's what I will do. I think the time I couldn't finish everything within the 10 minutes. So I will tackle recurring decimals in another video. I wanted to cover everything under rational in one video and then the other one in irrational numbers. But I need to explain this properly. So I will see you in the next episode where I'll tackle mainly recurring decimals under rational numbers. See you soon. Bye for now.